Okay, so let's look at the hierarchical clustering. So last time we did k-mean, right? And in k-mean is a partition clustering, right? Now we will look at the hierarchical clustering, and in hierarchical clustering we have two types, from top to uh, from bottom to up and from top to bottom, right? Today, but we will be looking at the bottom up, and also this is called as agglomerative clustering, right? So here I am going to make few assumptions because we are going to calculate the distance between cluster, and I will be using this Euclidean distance to calculate the distance between two cluster. That is the one assumption. And the second assumption is that I am going to use the single linkage clustering. What does it mean by single linkage clustering? So we will be in the situation where we will have two cluster, maybe with the three data point, and in this cluster maybe with the two data point. So and we are calculating the distance, right? So distance may be calculated as between these two cluster, or maybe between, not the cluster, between these two data point. So the distance of between these two cluster could be this distance or maybe this distance, right? So what does single linkage in single linkage clustering, what distance we take into the consideration is that which in the two different cluster, whichever whatever the data points are the closest, then we are going to take that distance, right? So if I take this example, then you see that here these two data points are the closest one, so we are going to take the this distance, right? Okay, and we will look at it. We have the different linkage, we have the complete linkage also, and in complete linkage we take the distance between two cluster, and in the cluster the distance between the farthest point data point, right? So this is the complete linkage cluster linkage, and this is the single linkage. So what I am going to use is for the example is the single linkage clustering, and next video we will look with the complete linkage clustering, right? Okay, now let me describe this bottom up or agglomerative clustering. So let me just tell you about the algorithm. So what we do, we will have some data points, right? And what we are looking is that we are finding the clusters between these data points, right? We are finding the clusters in the data points. So the first step would be, since it's a bottom up, so what we are going to do is we are going to consider each and every individual data point as a cluster. So at initial stage, I'm going to assume that every data point is a cluster itself, right? Now at the second step, what I'm going to do, I'm going to calculate the distance between each and every cluster. So this distance, this distance, this distance, and this distance, this distance, this distance, and this distance. So I have calculated the distance between every cluster. Now I am going to pick those two clusters which have the minimum distance. So maybe these two clusters are at minimum distance. So what I'm going to do, I'm going to merge these two clusters into one. So now we are left with how many clusters? One. We are left with how many cluster? One. Sorry, what happened? 1, 2, 3, 4, 5. 5 cluster. Earlier we were having 6 cluster. Now we are left with the 5 cluster. Now I am going to again repeat the same thing what I have done. Now with this 5 cluster, 1, 2, 3, 4, 5. With this 5 cluster, I am going to again calculate the distance between each cluster. So this distance, this distance, this distance, and this distance. So this distance, right? So there is one point to you will have to take care of this point, since we are using the single linkage clustering. So in this cluster there are two data points, right? So if I have to find the distance between this cluster and this cluster, then what I will look is the data points in the cluster that are the closest or that are the nearest, right? So I'm going to use this distance, right? So this distance I will be calculating, and 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 for this distance, and for this it is going to be this distance, and between these two cluster it is going to be this distance, right? Because these two data points are the near to each other, and for this we will calculating using this, right? Now we have each and every distance, and if you look, the minimum one is, and we are one left with this distance also, right? And any other? No, I think we have calculated every distance, and by looking at this seems to be near to each other. So what we are going to do, we are going to merge this into one cluster, right? Now again we will repeat the same process, but you will have to take care of this single linkage clustering. You see, in this cluster, if I will have to calculate the distance between this cluster and this cluster, then which data point we will pick from this cluster, that is the nearest one. So you are going to pick this distance to calculate the distance between two clusters, and we are going to calculate this distance, and now we are going to calculate this distance, right? Because in the cluster this data point is nearest to this cluster, right? So the smallest distance is this one, so we are going to merge this data points into one cluster. So let's merge this, right? So this is the again one cluster, and we are left with the three clusters. Now what we are going to do, again we are going to calculate the distance. So it will be calculated, we will be calculating this distance because this one is the smallest, this one is the nearest in the cluster, and this one is the nearest, right? So maybe after calculating the distance we will get to know which one is nearest, which one is the smallest. So maybe this one is the smallest, so we will merge this, and at the end this cluster will get merged with this one. So at the end we will left with one cluster, right? So this is the algorithm, this is how it works. And we draw a diagram that we call the, what we call, I forgot it, dendrogram, I think. Okay, let's take this example. So we have given this data point, right? And so what I have done, I have plotted this data points, right? And every p1, p2, p3, p4, p5, p6. So at the first step, what we are going to do, we are going to consider each and every data point as a cluster, right? So now we will have to calculate the distance between all these clusters, and this is the distance metric that we are going to maintain to track down that which one is the smallest, what distance, which two clusters are the nearest, right? So obviously that this is going to be 0, right? The distance between p1 and p1, right? And now we can calculate this distance p1 and p2. So distance between this cluster and this cluster, right? So we can use the Euclidean distance formula, and with this given coordinate we can calculate the distance. So it will come out 0.23. Similarly, we are going to do with p1 with p3. So it will be 0.22, and again p1 with p4 0.37, and p1 with p5 0.34, and p1 with p6, that will 0.24. Right? Now you see that since we have already calculated the distance between p2 and p1, so there is no need to calculate this distance, right? And between p2 and p2 it will be 0. So ultimately you will have the matrix with the lower triangular, you can say, right? So you will calculate the distance between p2 and p3, and what you will get is the 0.14, p2 and p4 0.19, p2 and p5 0.14, and p2 and p6 0.24. So no need to calculate p1 to p3 because you have already calculated. No need to calculate for p3 and p2 because you have already calculated. And between p3 and p3 it will be 0, right? And you will calculate 0.13, and here 0.28, here will get 0.10. So similarly you can calculate. So for p4 this will be 0, right? And for p5, between p5 this will be 0, and this you will get 0.23 and 0.22, right? And between p5, for p5 this will be 0, and here you will get 0.22, so 0.39, and between p6 and p6 it is 0, right? So this what we have calculated, that earlier what I have described you, that you will have to calculate the distance between p1, p2, p3, p4, p5 and p6, and with p2, p5, p3, p4, p6. So you will have to calculate all the distance between the pairs of cluster. Right, now what you are going to do is you are going to pick the minimum distance between clusters. So these two clusters are at the minimum distance, so p3 and p6. Now you are going to draw a diagram. So p2 and p3, what you are doing is you are merging these two, right? And now you will merge these two clusters, that is p3 and p6, right? And you will update your distance metric as like this. So now you will have with p1, p2. Let me make some space first of all. Yes. So okay. Now you will have p1, p2, and p3 and p6 is a one cluster, right? And p5, and there will be no p6, right? Similarly, here we will have p1, p2, p3, and p6, and p4, right? So now again, what you are going to do, you are going to calculate all the distances between all these clusters. This, right? And you will have to take care that between this cluster and this cluster, you will have to pick the data point. While calculating the distance, you will have to pick. So what you are going to do, suppose you are going to calculate the distance between this cluster and this cluster, right? Simply calculate this distance and this distance, right? And pick those distance which is minimum, right? Because what we are using is the single linkage clustering, and in single linkage clustering we take those distances which are the closest to each other, right? So so here if you see that this cluster, in this cluster, if you want to calculate the distance between this cluster and this cluster, then while looking at the picture you can say that you will pick this distance, not this distance, right? But if you have any confusion, like if this distance is greater or this distance, then calculate both these two distance and pick the smallest one, right? Then it will be the distance between this cluster and this cluster, right? So again you will calculate the distance and you will put this, right? So you will find that once you will calculate these distances, then you will find that the that this cluster and p4 is the closest one. So now you are going to merge these two clusters and you are going to track it. So what you have done is you have merged this p2 and p3 with this p4. Now here in this diagram, this height represents the distance, this height, right? So the smallest, so the closest cluster was this P3 and P6. Sorry, this P3 and, oh, I have written P6 here, it will be P6. P3 and P6. So these two were the closest cluster, and after that we have found, so this height will be greater than this height, right? Now again you will update your distance matrix, right? And now you are going to update like this. So now this time you will have P1, P2, and P3, P6, and P4 is in one cluster, and you will have P5, right? And here will P1, P2, P3, P6, P4, and P5. Now you are going to again calculate the all these distances. So this distance, so here you will have to calculate, maybe I don't know, maybe this one or this one. So you will have to see that which one is the closest, then that will be the distance between these two clusters. And here maybe you will have to again see that which one is the closest one, then you will have to pick the closest one, and that will be the distance between these two clusters. And again, distance between these two clusters and distance between these two clusters. So you have to again calculate the distance between all these clusters. So you will find that now this time P2 and this P5 is the closest one. So you will merge these two clusters as one. So P2 and P5, right? So now you will going to P2 and P5, right? So the height of this will be greater than earlier height, right? So you see that this height is greater than earlier this height, right? So now again what you are going to do, again you are going to find the distance between all these clusters, and again you will have to take care of the single linkage clustering while finding the distance, right? Now this time these two clusters will get merged into one, right? So you can merge these two clusters and you can track it down. So what we have done, that we have merged these two clusters, right? And at the end this P1 is going to merge with this cluster. So at the end you will have one cluster left. So P1, this one will get merged with this, right? And so what we call this diagram is dendro diagram, I think so. Okay, so I think what the use of this, that suppose you want to, so what you can do, you can make use of this diagram, and let's suppose that you cut this diagram from here, right? Then if you cut this diagram from here, what you will get is that all these individual data point, or you can say all these individual cluster. Now if you cut this diagram from here, then you see you will get how many cluster, 1, 2, 3, and in one cluster you will have this one, and in second cluster you will have this one, and in third cluster you will have this one, right? And if you cut the diagram from here, then in first cluster you will have these two, and in second cluster you will have these two, and in third this, fourth this, with this, right? Okay, now here is the complete algorithm, that first of all ensure nearby points end up in the same cluster, right? So the main idea of this bottom up hierarchical clustering is that we will have to ensure that nearby points end up in the same cluster, and start with some collection C in a single tone cluster. So every data point was a cluster, so that is why we are calling a single tone cluster, and assign each data point as a cluster at the first step. Now we are going to repeat the further steps until we are left with only one cluster. So what we are going to do is find a pair of cluster that is the closest. So we are going to find the pair of cluster that is the closest one, right? So how we are going to do, we are going to find the distance between these two clusters, right? And once we have found, we are going to merge those two clusters into a new cluster, right? And we are going to remove this Ci and Cj, which were the closest one, right, from the collection C, and we are going to add these two clusters into one, and we are going to repeat this step until we are left with one cluster. So this diagram is called dendrogram, right? So we are going to produce this dendrogram, right? And what this is the hierarchical tree of clusters. What does it is the hierarchical tree structure, and obviously we need to define a distance metric over the cluster, like this is the distance metric, right? So that you can use, and here we have used the equilibrium distance to calculate the distance between two clusters, and which distance we should consider between two clusters. Then what we have used is a single linkage cluster, and in single linkage clustering what we do is we pick those data points between two clusters which are the nearest, right? And that is all. Okay, so that was all about the hierarchical clustering, and in hierarchical clustering we look at the bottom up or the algometric clustering. Thank you.